Welcome back. Today's topic is calculation of ATC. In the last video lecture, we have discussed about how to compute available transfer capability. And in this video lecture, we will see simple calculations of available transfer capability. We have gone through simple formula for calculating ATC. We will employ that formula to calculate the ATC in this video lecture. I hope that by the end of this video lecture, you will be able to compute the available transfer capability. So let's start with question number 1, a simple question. The total transfer capability of a transmission line is mentioned as 2000 megawatts, which means TTC is equal to 2000 megawatts. And it seems that there is only one transmission line. It has been decided that 5% of the capacity will be kept aside as transmission reliability margin, which means TRM is 5% of TTC. So this will give to 5% of 2000. It is somewhere around 100 megawatts, isn't it? And it has also been observed that the existing transmission commitment ETC, what we call it as, on the above said line is 750 megawatts. So ETC, that is 750 megawatts. Besides, 100 megawatts is kept aside as capacity benefit margin. So CBM is equal to 100 megawatts. So what they are asking, available transfer capability on the transmission line. So they are asking ATC. You know the formula of ATC, TTC minus TRM minus sigma ETC plus CBM. If you substitute this, you will get the values of ATC. Very simple and direct problem. Yeah. Now you can see that the given TTC is 2000, TRM is 5%, and ETC is 750, and CBM is 100 megawatts. So available transfer capability is TTC minus this one, minus this one, minus this one. So what you will be getting? 1050 megawatts. This is a simple calculation of ATC. Now we will move on to problem number 2. Shown on the board is a problem where there are 3 bus. There is a 3-bus system. If you carefully see, there is a 3-bus system, and it has different paths. And each path is having number of lines. So this path is having 4 lines. This path is having 4 lines, 2 lines, 2 lines. And each line there is a TTC and initial path reservations, what we call it as existing transmission commitments. Okay, so now what they are asking us, they are asking us to sketch the above power transmission system and determine the total transfer capability of each path, ATC of each line, and ATC of each path, neglecting the margins. Okay, first of all, let's try this line, this path, which means that how many buses are there? There are nearly 3 buses, right? So you will be getting like this: 1, 2, and 3. Bus number 1, bus number 2, and bus number 3. And in this path number 1 to 2, there are 4 lines, which means 1 to 2, 1, 1 to 2, 2, 1 to 2, 3, 4 lines. And these transmission lines in this path can be employed in either direction, from 1 to 2 or 2 to 1. So these are the 4 lines, in 1 to 2, in this direction, and also in this direction. Next, between 1 to 3, there are 2 lines. This is 1 to 3, 1 line. This is 1 to 3, 2 line. Okay, so this is the representation. So in each of these lines, as already said, TTC of 1 to 2 is not equal to, ATC of 1 to 2 is not equal to ATC of 2 to 1, right? So that's why they have mentioned separately. Okay, paths are different, which means it indicates a starting path to ending path in which power is being transmitted. So now they have got each line TTC. So path TTC is the combination of all these 3. So what is a path TTC? Which path it is? 1 to 2 path, right? So TTC of 1 to 2 path is summation of all these things. 7 plus 5, 12, 20, 2600 megawatts. Similarly, for this one, what is the path TTC? Path TTC of 2 to 1. How much? The summation of all these three things? 22. Like this. Summation of paths. Okay. Now, and each line is having now initial path reservations. If you can see, so since the margins are neglected, line TTC minus path reservation gives you ATC. That we have done here. Yeah. So you can see this. So this is the data which has been given for you up to here, right? So line ATC, how will you calculate? Since there are neglecting margins. Okay, what is ATC? ATC is equal to TTC minus margins I am neglecting. What were the margins? TRM minus ETC minus CBM, right? So I am neglecting these two. So my formula is TTC minus ETC. So 500 minus 400, it is 100. 600 minus 200, 400. 800 minus 200, 600. Like this everywhere. This is my line ATC. So if I want path ATC, I should add these two. And if I want path TTC, I should add these two. This is your path TTC. This is your path ATC. And path reservation, this is your path reservation. Just summing up of all these things in a particular path. So this is the way how we will use path ATCs, path reservations, and path TTCs. Now let us suppose there is a request. If there is a request of 600 megawatts from customer 1 to customer 3. Is it possible? Which means that on the path of 3, I should see whether ATC 600 megawatts is available or not. Now, if you see 1 to 3, what is the path ATC? This is a path ATC, 1400 is there. So 600 megawatts is possible. And we do have two transmission lines. The choice is yes. Either you can share it equally among these two lines, or you can utilize only one line. The sharing is up to you depending upon your technical constraints. Let us suppose if they ask you somewhere around, let us suppose they will ask you some 1500 megawatts. Is it possible from 1 to 3? No, it is not possible because we do have only 1400 megawatts. Okay, so like this we will be doing the problems. Okay, now question number 3. See, there is a transmission path from bus 1 to bus 2 and it has 4 transmission lines, each with 150 megawatts TTC, which means there is a path from 1 to 2 and it has 4 lines, 1, 2, 3 and 4 lines, and each line has a capacity of 150 megawatts. And it has been decided 25% of the TTC of each path will be kept as TRM. On which line they are not saying. 25% of TTC of each path. And it has also been observed that initial reservations of each line are 75, 50, 100 and 130. Besides 50 megawatts of the path. On which line? It is your choice. Okay. Determine the ATC of the path. What is your idea of picking lines for maintaining TRM? Is there any possibility of transferring 50 megawatts on the path from bus 1 to bus 2? Let's see this one. This is the data. 4 lines were there. And this is the line TTC, each one of 150 megawatts. And this is the initial path reservations. I have summated them to get the path TTC. This is the path TTC 600 and this is the path ATC 355. So the remaining capacity is 245, and in this one you should keep 2 margins. One is 20% of TTC, which is equal to 150 megawatts. Okay, the other one is 50 megawatts. So out of this 245, you should keep 150 for TRM and 150 for CBM. So which lines you will choose? It is your choice. So 150 I have chosen in this fashion. First of all, I have chosen the least one, next least one, next least one, and the remaining I am going with this one. So, and CBM also. So, since all these lines will be already filled, so I will be choosing this one. So, now this available capacity minus this margins. If I keep, I will get the net ATC. So in this one 75, I'm keeping it as CBM for TRM, and so I'll get 0 ATC. 45 here, 0 here, 0 here. This is my final ATC, path ATC. And these are line ATCs. Now the third question states that, is there any possibility of transmitting 50 megawatts of power over this entire path? No, there is no transferability. If you want it, you should either reduce this CBM, or you are supposed to reduce this one, or you are supposed to curtail any of these transactions. That is the only possibility for transmitting 50 megawatts of power. Okay, so that's it for today. Hope you have understood how to compute ATC for simple problems. Okay, thank you. We'll meet in the next lecture again.